Hello and welcome back to Haskell Live Coding. So right now we're going to move on to step 3 in the FASTA algorithm, which is rescoring the diagonals. So right now I have this diagonal info data type with the score and the start and stop. And the score is what's going to be rescored, because right now this score just represents the number of blits, the number of on bits in this dot plot. But what I really want to do is using the start and stop. I want to look at the original strings and basically assign a positive score to matches and a negative score for mismatches. So if I were to rescore this diagonal down here, we can see that it goes from A to, we can see that it goes from index 0, 1, 2, 3, 4, 5, stopping at 6, but remember we add on k minus 1, because really this blit on means that the next k characters, including this one, match. So we're gonna walk from basically A, T, C, G to the end, and we're going to compare it to these characters right here. So we would say the hit score is 5. This diagonal will be rescored to 5, 10, 15, 20, and it's done. Where the mismatches come in is when there's a gap in the diagonal and then it picks up again. And so if I was to score this big diagonal, it would be, and I'm looking at the characters here and ignoring the blitz for now, it would be 5, 10, 15, 20, 25, and here's a mismatch, A to C, so that would be go down to 21, then T matches T, 26, C matches C, 31, and finally G matches G, 36. So that is how the rescoring is going to go. Okay. So I'm going to make a function called rescore diagonals. It's going to take the original strings and it's going to basically modify this diagonal, diagonal scores. Remember, this is the diagonal scores is a map. So I'm modifying each element, so I'm going to map over it. And my argument to this function is one diagonal index. So with this diagonal index, what do I want to do? Well, I have the full strings S1 and S2, and the information in the diagonal index can allow me to map those strings to substrings, which is what I'm really after. So I'm going to do something like this. Let S1 prime and S2 prime equal, diag info substrings of S1 and S2, and I also need the diag index, which is where that start and stop information is, and then once I have the substrings, I'm basically going to have a function score, or substring score or something like that, or score strings. This is going to take two strings and score them, and that's going to return an int, and with that int I want to set the diagonal index's score to it. So diag index, this is going to be, set that to that. And what are you complaining about? Well, I already know this is not quite right, obviously, because I haven't written these two helper functions. So let's start with diag info substrings. And this is going to take 2 strings and a diag a null info. And I'm going to return 2 substrings, so I might as well just put them in a tuple, because that's what I did down here. Okay, so an easy way to get a substring is to do a take after a drop. So if I have indices, let's say a substring that goes from 5 to 5, and both of them are inclusive. So what I need to do is first call drop 5 on that list, which will drop indices 0 through 4. And then I need to take the difference between 5 and 5, which is 0, plus 1, because they're both inclusive indices. And I'm going to do that on 2 different strings, using the values in my diagonal info dot dstart, which is a tuple, and diagonal info dot dstop. So I'm just going to call the first number that I want to take. I'm going to call it, or I'll do the drops first. Drop S1. I'm going to drop, and I want to drop the start, because if the matching starts at index 5, I want to drop 5. So I need to get at the first element in start. And I don't know why I call this D's. This is a diagonal info. So this is rename that right quick. And I'll do the takes. So basically I want to take stop minus start plus 1. And finally, in, so it's going to be a tuple, and my first string is going to be, I'm going to take after drop. On S1, and similarly take after drop on S2. Okay, now what I'm going to do is write this function right here, score strings, and this will be a simple one. Score strings is just going to take 2 strings and return an int. And what I'm going to need to do is I'm going to keep adding to my list of basically settings hit score, miss score, corresponding to the point value of a hit and a miss. So that when I'm scoring the strings, all I need to do, let's do a base case. Score chars on x and y, and add that to score strings x's and y's, where score chars just takes 2 chars. Sorry I'm going so fast, but I think this function's pretty simple. Score chars c1, c2 equals okay, and finally, since I never want to call score strings with 2 strings of different sizes, I'm just going to throw an error. Okay, so I have errors. Parse error, that's what was going on. Oh, so I didn't close this off. That's probably a good one. Not in scope. So this is a simple setter. Forgot to grab it. And this should be a lens and not the actual map. So I want to set the score to that on that. And finally, looks like I forgot to put D's here. So there we go. Shadowing existing bindings. Okay, here's what I'm going to do about that. Since these aren't at all settings to the function, they're just little convenience strings. I'm just going to preface them with an underscore. Bring them all the way down here. Try compiling. It compiles with just some warnings. That's okay. I'm also going to save some time by hard-coding my dot plot. And then my diagonal scores, the initial ones, before I rescore them, that takes the length of the first one and the dot plot. And with these in place, then I should be able to, in GHCI, call rescore diagonals with the 2 strings and the diagonal scores, and I should get back the rescored versions. So let's try it. So there's my initial scores. Let me pull this up. And again, I set the threshold to 0, so none of these got filtered out. But if the threshold was 2, for example, then this diagonal info would be filtered out because it has a score of 1. The other 2 would remain. So now I'm going to rescore the diagonals and see if it worked. Okay, so at first glance it looks like it did because the calculation I did earlier with the long diagonal being 36, that looks right. But let's just take a closer look. So the diagonal at index 6, which would be 0, 1, 2, 3, 4, 5, 6, this one has a score of 20, and that's because starting here and going to the end, I match 5, 10, 15, 20. The 36 I already did, and this diagonal, which starts and ends at the same spot, which remember is the length 3, has a score of 15. So it works. We're done. Yay! Alright, thank you for watching, and I'll see you next time.